This podcast is presented by SCHOTT. With over 130 years of experience delivering innovative, high-quality products, SCHOTT is the global leader in specialty glass, glass ceramics, and other innovative materials. With a direct presence in over 30 countries, the company is a highly skilled partner for several high-tech industries, including defense, semiconductors, data communications, optics, energy, automotive, aerospace, and healthcare. One of SCHOTT's key goals is environmental protection corporate-wide, and it is committed to being the first specialty glass manufacturer in the world to be climate neutral by 2030. Thank you again to our sponsors at SCHOTT for helping us present this podcast to you. Hello, and welcome to the Emerging Tech Horizons podcast. I'm Mark Lewis, the Executive Director of NDIA's Emerging Technologies Institute. And on this podcast, we will focus on ETI's report launch on the future of hypersonic supply chains. It's an event that took place on May 11th at NDIA headquarters, and I hope we will draw your attention to a piece of work that we're all very, very proud of. To discuss this report, my guest today is one of our very own research fellows, my very good friend and colleague, Rebecca Wostenberg. So let me tell you a little bit about Rebecca's background. She joined the Emerging Technologies Institute as a research fellow in April of 2021. She was actually the third employee of ETI. I was employee number 2. Rebecca currently is leading the Emerging Technology Supply Chain study, aforementioned, which is a multi-year research effort designed to assess the state of defense emerging technology supply chains and provide some policy recommendations for their development, health, and resilience. The way I like to say it is, if you want to build lots and lots of hypersonic weapons or lots of direct energy weapons, what do we need to put in place now in order to make that happen? Prior to joining ETI, Rebecca served in the Secretary of Defense's Action Group, the SAG, in the Department of Defense. She directly supported 2 Secretaries of Defense on long-term strategic planning, industry outreach, and the National Defense Strategy implementation. And in recognition of her outstanding service, Rebecca was awarded the very prestigious Secretary of Defense Medal for Outstanding Public Service. And also, as an aside, I had the privilege of working with Rebecca in that role. Prior to that, she worked in the Office of the Undersecretary of Defense for Policy, and before that, she served before serving the Department of Defense. Rebecca worked in the think tank community as well as in Capitol Hill. Received a Bachelor of Arts in Political Science and German from Franciscan University of Steubenville, and a Master of Arts in Statecraft and National Security Affairs from the Institute of World Politics. Rebecca also conducted graduate coursework at Oxford University, Christchurch College in the UK. So first, please join me in welcoming Rebecca to today's podcast. Rebecca, thanks so much for being on this episode.
Thanks so much for having me, Mark.
So I'd love to dive right in. Can you start by sharing why we decided to launch this emerging technology supply chain study and what the goals were when we first started out?
Absolutely. So obviously, over the past few years, we have seen a number of world events that have really shown the fragility of U.S. supply chains across different sectors. For instance, with COVID-19, more recently with the war in Ukraine, it has become very visible the challenges that the U.S. faces in supply chains. And those sort of world events and the kind of the reality check that they provided sort of was the impetus behind a lot of different efforts across the government and outside of government to try and address some of these issues. In both the last administration and this current administration, you have seen a series of executive orders trying to get at these issues, and then a series of different reports responding to those from different departments and agencies. Within Congress, you saw the House Armed Services Committee a couple years ago launched a defense supply chains task force with the large report that they put out after that. Even outside of government, a lot of different think tanks in the Washington, D.C. area and beyond have launched different efforts in this regard. Those efforts have covered a lot of different supply chains across a lot of different sectors. But one area where there hasn't been a lot of work is in defense emerging technologies. And so that is the void that ETI seeks to fill with this study that we launched. There's an opportunity here looking to the future of, like Mark said, what are the supply chains that you need in place in order to support fielding these emerging technologies at scale and affordably. And so the effort we launched has two goals in mind. First is to assess the state of defense emerging technologies, supply chains, and second, to provide actionable policy recommendations to try and get at these issues. So we're not just admiring the problem, but trying to provide recommendations of how to really get at them.
So who's the target audience?
Yeah, so we kind of have several different ones. So I think first and foremost, you would expect policymakers. So the Department of Defense, obviously the different offices that deal with emerging technologies there, Congress for sure. But given ETI's unique position as part of the National Defense Industrial Association, we also want to identify opportunities for industry. So I would add them as a key audience for this report.
Right. So let them understand what the demand signals are, as well as what they need to do to meet the needs of government.
Exactly.
So that sounds great. So you mentioned, that ETI kind of is in a unique position given its situation as part of NDIA. Could you expand a little bit, given all the supply chain work currently being conducted? What makes ETI's efforts so unique?
Yeah, so I would say number one, our goal is to be complementary to all of those different efforts. We're not trying to reinvent the wheel here. We're not trying to duplicate efforts that are out there. However, there's sort of two things I think that make us unique. And the first is what you just said, Mark, is kind of our unique position as part of NDIA. We have this incredible member base to draw on when we're conducting this research. We have thousands of members and member companies that we can work with that really make up these supply chains. And so as part of this effort, we met with them. We conducted a series of working groups that I'm happy to talk more about in a little bit, but to really hear what are the issues that they're facing. So industry is a key part there, but we also wanted to bring in academia and government to hear from all the different perspectives and bring those together. So I think our unique position at NDIA is kind of the number one thing that makes us unique. And then the second thing is the area that we're focusing on. There's certainly work being done inside of government when it comes to defense emerging technology supply chains, but there's not as much being done outside of government. And so that's really what our focus is and what makes us unique.
Excellent. I always like to point out at NDIA, we've got 60,000 individual members, 1,800 member companies that we can draw upon their expertise, the convening authority of NDIA. So yeah, I absolutely appreciate that. So you mentioned how your methodology. Could we dive in? Tell me exactly what the research team did, how you approached this issue.
Sure, absolutely. So let's see, there's a number of different pieces here that I'll try and unpack. So when we first launched the effort, we decided to partner with one of NDIA's member universities, the University of Maryland, and partner specifically with their Supply Chain Management Center, where we worked with a team of professors and graduate students to really try and map these supply chains. That was kind of step number one, and that formed sort of the foundation of our research. In addition to that, we conducted a series of working groups. We had 8 different working groups with over 20 participants from industry, government, and academia, all throughout the different levels of the hypersonic supply chains. And each of these working groups was convened around a specific aspect of the supply chain. So we covered 4 areas. The first was critical raw materials and goods. The second is manufacturing base and workforce. The third, supply chain security and vulnerabilities. And fourth, we looked at the international partnerships piece. And so we convened those working groups, and that provided a ton of insight that we were able to use in our research. From there, we also conducted a significant amount of internal research to support that, compiled all of these findings in the report that we launched, and is available on our website. And kind of the final step before we published that was submitting it to what we called our peer review committee. And here we had a group of distinguished individuals with extensive experience inside of government and industry to provide their input. So we had people like the Honorable Mac Thornberry, former House Armed Services council committee, chairman,
Yeah.
and other individuals that provided their input on this final product, having come from that policymaker role. So that's just a little bit of insight into the methodology that we followed.
Very good. Very good. And again, I absolutely resonate on your observation that I don't know of any other organization that is quite in the position to be able to pull all those stakeholders together from outside of government and get those perspectives. Okay, so we've already we recently launched the report. So let's dive into some of the findings. What did we learn?
Let's see, there is a lot to unpack here in a 60 plus page report. So I'll just kind of do the wave tops version. And I would encourage all of our listeners to check out the full report available on our website.
Okay, and it's an unclassified report, so anyone can go to the website and download it, right?
Exactly. Yeah, Mark, I think you point out a very important point there that I'll kind of hammer on for just one moment. Is we did decide early on to do a publicly releasable report because we thought that these issues are important enough that we wanted to get it to the widest audience possible, especially with industry in mind. So like I mentioned, the structure that we followed was those 4 different components of hypersonic supply chains. And I'll try and unpack a little bit about the assessment portion, and then I'll dive into some of the recommendations that we made. So overall, our assessment was that current hypersonic supply chains are insufficient when it comes to manufacturing base, workforce, testing infrastructure, and a number of other issues to support fully fielding hypersonics in the future at the scale that they need to be and affordably.
Right. So let me hold that point. So right now we've got a lot of demonstration programs, a lot of, we've got efforts at DARPA, efforts at the services, but to be clear, you're making the definitive statement. We're not where we need to be if we cross that valley of death and get those make them real weapons in the hands of our warfighters. Is that a fair summary?
Yes,
yeah.
That's spot on, Mark. Yes, 100%. And so what we tried to do was sort of assess different aspects of the supply chain and really found some interesting insights. Some of them are applicable across different technologies, and some are very specific to hypersonics and the needs that are found there. So I'll just highlight a couple, starting with kind of critical raw materials and goods. A common topic in conversation now about supply chains is the U.S.'s reliance on China when it comes to rare earth elements. Essentially, what we found is that China exports of rare earths account for 74% of U.S. rare earth imports. So there's a huge amount of reliance there. Rare earths are necessary for hypersonics, in particular for parts of nozzles and those types of things, high temperature materials, etc. Another area of vulnerability that we found within the critical raw materials area is the lack of suppliers when it comes to other high temperature material items. So something like there's only 3 suppliers of the carbon-carbon composites needed for hypersonic vehicle coatings. So you have a lot of different issues, especially in this high temperature material area, as Mark, you are very well aware.
Yeah, absolutely. One of the defining features of a hypersonic vehicle, it gets hot.
Exactly. And I think the last point that I would make on critical raw materials and goods that was particularly interesting to me was the limited number of DoD-approved domestic suppliers of ammonium perchlorate. Obviously, this is not just for hypersonics as a necessary component of rocket engines. This covers a wide variety of different sectors. But for many, many years, there was only a single supplier here. However, we found that recently that supply base has expanded to 2, which is a positive move, but only time is going to tell if that's sufficient, especially when it comes to scaling up hypersonics. So that's a little bit about the critical raw materials assessment that we made. Now, when it comes to manufacturing base and workforce, Mark, you already elaborated a little bit on this, is you have this dynamic at play where the history of hypersonics has really ebbed and flowed over the years. Sometimes it is an obvious priority. There's a lot of money, a lot of efforts in this area, and you see growth in the manufacturing base. But then that interest and that emphasis has ebbed over the years too. And so you've seen that affect the industry as a whole. And what you end up with is a very small manufacturing base. And so that's one of the struggles that we found, is that there's an insufficient hypersonics manufacturing base due to inconsistent demand signal. And that's something I'll talk a little bit more about when we talk about the recommendations that we made in the report. Like you said, Mark, the manufacturing base that exists is really focused on different test vehicles, onesie-twosies, not the scale that it needs to be at. Another area that we found to be a significant challenge is the testing infrastructure. The testing infrastructure that's necessary for hypersonics, it's old, it's aging, and there's a lot of competition out there between hypersonics and other programs that exist for these facilities. Especially when it comes to other programs of record, they are a higher priority and they're going to get access to the facilities. And so that's a constant struggle when it comes to hypersonics.
That's especially true in flight testing, if I'm not mistaken, right?
Exactly.
You've only got so many ranges and you want to test your new weapon, but there's an F-35 test, maybe a B-21 test plan. Yeah.
Exactly. So when it comes to hypersonic talent and the workforce that's necessary, we tried to kind of break that down. What exactly does that look like? I will say this was an area where it's challenging to get data on workforce because you're dealing with so many different sectors that some of them are very hypersonic specific, some are hypersonic adjacent. But some of our key takeaways, especially from the working groups, is that, again, the hypersonic workforce faces a dearth of talent because of the volatile history of the technology, that there hasn't been a consistent demand signal. And so the workforce simply doesn't exist today at the scale that you need it. Workforce was an area that we saw there were a lot of different areas for improvement that we tried to get out with some of our recommendations. So then the third area that we assessed was supply chain security and vulnerabilities. And I'd like to just talk through two specific ones here, but obviously we talked about a lot of different ones in the report. First is the challenge of cybersecurity that hypersonic supply chains face at all different levels of the supply chain. And I'll just give one example that we highlight in the report is cyber challenges even at the level of mining. You saw reports within the past few years of some very interesting information operations conducted at Australian and US rare earth mining companies, allegedly emanating from China, and really focused at undermining these companies. There's speculation out there that this is because the Chinese feel threatened with their dominance in rare earths by these companies. So that's just one example of the type of cybersecurity threats that exist at all different levels of the hypersonic supply chains. One other area, one other vulnerability that we looked at was an interesting analysis of China recruiting talent from the Los Alamos National Lab to work on their hypersonics program. This is something that has been a significant challenge over the years. There's been some very interesting analyses done on it, but is another supply chain security issue that's faced. Finally, we looked at international partnerships in our assessment. And here, there are several different international partnerships that exist, especially between the US and Australia, under the AUKUS agreement. And our assessment was that the international partnerships that exist are great, but there's opportunities to expand that can help benefit different parts of the hypersonic supply chains, especially when it comes to things like testing infrastructure. And so I'll talk a little bit more about that, but I think those are kind of our key assessments. So next, I'll dive into a little bit about our recommendations.
So before we jump into recommendations, I want to actually especially come back to some of the security implications. So, are there things that are unique about hypersonics as a discipline that make it especially vulnerable to some of the uh, um, nefarious activities that our competitors might participate in?
Yeah, so there's a lot to unpack there. I think the short answer is yes. Especially if you look across the board, both Russia and China have very aggressive hypersonic programs. And you have seen some significant tests done over the years. Essentially, there's been some reports of Russia using hypersonics in Ukraine. The Chinese have fielded a number. So there's certainly issues like that we're facing. And so it makes, because they have these programs that exist, there are vulnerabilities there. So those are some of the major supply chain security issues that we face. I will say one other is the supply chain of hypersonics is incredibly long and incredibly complicated and incredibly detailed. And when you look at especially the smaller companies that sit in the supply chain, they don't always necessarily have the capital available to really invest in cybersecurity for their companies. And so there's vulnerabilities that could exist there. And so that's a real challenge that that needs to be addressed in the future.
Yeah, no, that absolutely makes sense, and not a problem that's unique in hypersonics, but a problem that is especially acute in hypersonics. So, absolutely, that makes perfect sense. Okay, so you said you had policy recommendations.
We do.
Please tell me what they are.
Absolutely. Again, there are many, many different recommendations that we make throughout the report, but I'll just go ahead and provide a few, a flavor of them here on the show. So I think number one, the most important thing that the Department of Defense can do to strengthen hypersonic supply chains is to provide a consistent demand signal to industry. As I mentioned before, Mark, as you have mentioned, there's a volatile history here. It has ebbed and flowed over the years. And so the number one thing the Department of Defense can do is to provide that consistent demand signal. Obviously, that can take the form of a program of record, actual contracts, but senior leaders coming out and saying this is a priority for the Department of Defense and continuing that over the years so that industry has that demand signal and can act on it and expand their capabilities to then support that. So I think that would be number one. Then we made recommendations throughout these different issues that I mentioned before. So for example, one area that industry can do more is investing in things like carbon fiber and expanding the supply base there. Again, this is one that carbon fiber is a very specific component that's needed for hypersonics, but it has a wealth of other applications in mind that can help with expanding that supply base. So this is an area where there needs to be further investment, there needs to be expansion in industry. But again, you need that demand signal from government that there will be a need for this in the future. Next, one of the things that we recommended is that DoD should continue to pursue an air-breathing hypersonic vehicle system plan. And this really comes down to trying to make sure it has a variety of different applications, but one of the key focuses is making sure that that knowledge that's gained is transferred to the next generation of the hypersonics workforce. And I know, Mark, this is something that's near and dear to your heart.
Near and dear to my heart. And, of course, stepping back, two basic approaches to hypersonic weapons. There's the air-breathing, the jet-powered, and there's the rocket-powered, the boost glide systems. And most of the department's programs are boost glide systems, but there are wonderful applications for the air-breathing technology, cruise missiles, for example. And I'll note the Air Force has recently stated a laser focus, no pun intended there, on the air-breathing applications. So all good news, and obviously I resonate with the recommendation.
Definitely. So continuing on the theme of workforce, another recommendation that we made, and this time it was looking specifically at academia and the role that they can play, is academia should be leveraged for educating that mid-level talent that exists in hypersonic adjacent fields. There have been some efforts to do this, either companies bringing in that academic talent to help, that sort of thing. And so this is a good step in the right direction, but much more needs to be done. And so we saw this as an opportunity to really leverage academia in that regard. I'll also say on the education front, we need to make sure that we have an acquisitions workforce that is ready to and adequately trained for dealing with hypersonics. It's a complicated technology. There's a lot there. And so in order to fully field these, we need an acquisition workforce that's ready. And then on the international partnerships piece, I would highlight sort of the opportunities that exist to expand on partnerships, especially when it comes to Canada and Australia. We specifically recommended that the US should look to those countries to diversify its critical materials supply base. And then also for testing infrastructure, there could be an opportunity both in the short term to do more testing, to expand testing, especially when it comes to Australia, or in the long term to expand testing facilities with those particular countries. And so we recommend that in the report. So that hopefully just gives a little flavor of some of the recommendations that we made throughout our report.
No, and those all make sense, and especially on the testing side, I think there are a lot of people recognizing that that's become a bottleneck. We've allowed wind tunnels to atrophy. Our flight test capabilities are, I guess the word I would use is complicated, and so yeah, I mean, I think those recommendations should absolutely resonate. And I would say, good news story is we are seeing people stepping up to the plate. The Test Resource Management Center under George Rumford has been, very, very much focused on fixing some of the test infrastructure issues. His hypersonics lead, Jeff Wilson, has been doing a phenomenal job of renewing investments in test capabilities. But we always have to be mindful of that, and we always have to keep pushing that.
Yeah, I completely agree, Mark. And that actually brings up another recommendation that we made when it comes to testing is that the department needs to increase that testing tempo. You've started to see an increase there, but it needs to continue if we are going to move fast with this for actually fielding these technologies.
Yeah, and again, I couldn't agree more. And again, there's kind of a good news story that there are programs in place now. There are people stepping up to provide rapid testing, responsive testing. I'm a big fan of recoverable testing, so you actually pick the thing up off the ground after you've flown it to see what it looks like. Ideally, reusable test beds. I think all ultimately really important to get our test base up. So that hey, look, so that's all great. And of course, now hypersonics was just step one. You're looking at a broader range of technologies. So not to diminish anything that we've done in the hypersonics realm, because I think I'm slightly biased, but I think it's a very impressive piece of work, extraordinarily timely. Tell us what comes next. What's the next study topic, and how do you? What's the timeline for new topic areas?
Of course. So the next technology that we are currently looking at is directed energy. And we're going to look both at high energy lasers and high powered microwaves with that study. And we're going to follow a similar methodology to hypersonics, especially when it comes to the working groups. Those are currently underway, meeting with industry, government, and academia on both HELs and HPMs to really assess the state of those supply chains.
High energy lasers, high powered microwave.
Yes,
yeah.
Thank you.
Okay.
Thank you.
Yeah.
So, like I said, working groups are currently underway. And then again, we'll follow a similar methodology. We'll do a series of internal research and roll that product out as well once it goes through the peer review committee, et cetera. So we're really excited about that. And then we'll see in the future about exploring other technologies. I think there's a lot of opportunity here when you look at the different emerging technologies, maybe to look to things that are even further in the future, something like quantum or biomanufacturing and the supply chains that are necessary there, where there's great work being done. But we need to say, okay, 10 years, 20 years, 30 years from now, what are the supply chains that need to be in place to support those technologies for the Department of Defense?
And what are the steps that we need to take as a nation to make sure that that comes to pass?
Exactly.
Yeah. Rebecca, first of all, thank you to the whole team for the work that has been done in this area. I'm very proud of that report. It was actually the first major report of its type that ETI has produced. We're still a fledgling organization, so I'm very happy with that, and looking forward to the other products of this multi-year effort. I think it's going to be incredibly impactful and incredibly helpful as we move forward in delivering these emerging technologies.
Couldn't agree more, Mark.
Okay. Rebecca, again, thank you so much for joining us for this episode. Before we lose the audience, I want to remind everyone that we've got a number of Emerging Technology Institute events coming up, but the key will be on August 28th through 30th, 2023. We will be holding the first annual Emerging Technologies Conference at the JW Marriott Hotel in downtown Washington, D.C. It will be the Emerging Technologies conference of the event of the year, of the decade, of the century. Please look for more information that will be appearing on our website very, very soon. Again, thank you to everyone for listening, and have a good rest of your day.